All right, continuing with section 4.4. The last counting rule that we're going to talk about is the combinations rule. So remember, you use combinations when order doesn't matter. Okay, so if ABC would be considered the same thing as CAB, that is called a combination. And the formula for that looks kind of similar to the one for permutations. This formula is also built into your calculator, so I'll show you how that works. All right, so let's look at an example. Lotteries are a good example of combinations. So in California's Fantasy 5 lottery game, winning the jackpot requires that you select 5 numbers from 1 to 39. The winning numbers can be drawn in any order. Okay, so as long as your ticket has the same numbers as the numbers that are drawn, doesn't matter what order they're in, you win the jackpot. So the first question is, how many different lottery tickets are possible? And then once we figure that out, it should be easy to figure out what's the probability of winning the jackpot when you purchase one ticket. Okay. All right, so that would be an example of a combination because it doesn't matter what order the numbers are drawn. So there are 39 numbers available. You have to select 5 of them. And again, since order doesn't count, we're looking for the number of possible combinations. So that would be using this new formula. You put in these numbers, and again, this formula is built into the calculator, so you probably don't have to put yourself through all this. And it turns out that 39 choose 5. I forgot to mention that the way that I read this expression is N choose R. Interestingly, there's nothing that I know of equivalent to that for permutations. I just read those as NPR. Yeah, but I read this as N choose R. Okay. So that turns out to be 575,757. That's how many different possible tickets there are. Okay. So real quick, I am just going to bring up my calculator here, and let's get rid of this stuff. Okay. So the way it works on here, let me do this. No, actually, I'll leave it like that. Okay, so you do 39, and then press math, and then go over to where it says PRB. NCR is number 3. Okay. So you hit that, and then hit the number 5. Okay. So there's that same 575,757. On the scientific calculator, I'll step over to this side. You would press 39 and then press PRB, and then I'll bring up that menu on top. NCR is right in the middle. You hit enter on that, hit the number 5, and you get the same answer. All right, so since there are 575,757 different possible tickets, selecting the one that ends up winning, the probability of that is 1 over 575,757, and then they make this little comment. Typical lotteries rely on the fact that people rarely know the value of this probability and have no realistic sense for how small that probability is. This is why the lottery is often called a tax on people who are bad at math. I have never completely bought into that idea as much as a lot of people have. I mean, yes, the vast majority of people never win big money in the lottery, but if you're the person who does, you know, and somebody has to, so I figure it might as well be you. I hardly ever play, so, okay. But that's how the combinations rule works.